In this episode of Finno-Ugric Machining, we are going to make the attachment for the cycloid drive, which is binding together the motor and the itself the cycloid drive, and is attachable to the rotating welding positioner. So, well, what I'm going to use is this piece of material. There are some problems with this one. First of all, this surface here is flame cut. It's very rough and it has some hard spots on it. So, if I would just put my high-speed steel roughing end mill into that one, it would become a former roughing end mill. So, therefore I need to use some special cutting tools for this one to get rid of that portion. And so my first task is to make this a usable piece of material. So we have the workpiece here and some hardware to attach it to the milling table. So my first task is to create in either side of this one, this side or that side, flat surface, so that I can attach it securely to the table. At the moment this workpiece is crooked, but I have been done some filing here, cutting high spots, etc. So that, and this is about the I have positioned the milling table so that this is about in the center of the travel, so I don't run out of it. And also I know that this groove here is also quite near the center of my travel. So, these are laying flat there, and then I just put this on top of those. And why I'm putting parallels there under? The reason is that we have this flame cut surface here, which is really proud. I couldn't file it. It's so hard that I cannot file it. So now we are there, and I have to see it, and then see that it's that the parallels are properly there under. Well, yeah, they are not. It's so easy to get them away. So I check that it doesn't wiggle too much. It has some wiggle to it, but not too much. So now I just attach it there. So I think we are there. Yeah. we have established the two stripes here, which are fairly good. The surface is actually really good. And they are also on the same plane and straight. So now when I flip this around, I can put my parallels on those, and it will be repetitive, so I can repeat easily. That's well. Well, now dialing in for the next surface. Well, this time combination square would be two cars instrument for this. Well, this is the surface I just milled on the other side, so I have flipped this around, and then I have also eyeballed it into place, depurred it, and etc. Okay. So now what and here we have a magnetic stand in this support thing, and yeah, when you are doing this, it's quite important that you lock the axis which you are measuring. In this case, I mean that you have to lock the y-axis. Since if I now start knocking this, it might move the table, and then your measurements would be bullshit. Yeah. So now I have made it so that yeah, the y-axis is locked, and I have also zeroed this dial indicator here, and now I start sweeping this around, and I see that it's starting to become high, so I knock it just a little bit. It's tighter, it's tight in this end, so it pivots from this end, okay? Maybe I should tighten it a little bit more because it's so sensitive. Well, it's really sensitive, it doesn't need any more than that. Well, okay, let's go back and see where we are. Well, we still have 500ths of a millimeter to go there. Now I loosen the y-axis and zero my dial with this one. There you are, lock it back again, and then we go. Okay, now it's the other way around. A little bit. No, it's this way around. it needs very little. It's something like really little. Okay, let's see if I got it near. And yeah, you always measure to the same direction. Well, it seems we are still... Oh yeah, okay. We need to put it even more there, like that. Then I would like to tighten this even more, because it seems like it's pivoting somewhere in between. Okay. And this is in 0, good. 0, 0, 0, 0, 0. Very good. Now we have two parallel sides, and as you could probably see, I also made it to a certain dimension. Well, the certain dimension is 98 millimeters. Well, it's irrelevant what that dimension actually is, but I wanted it to be something like exact millimeters. It's easier to do. Oh, this is tight. Do future checks with that one. Well, now it's about 100 under each end. They are parallel, but the dimension is a little bit under. So now I would like to deburr these corners, and I can see there is a crisscross pattern here, which means that the cutting tool has been cutting both in leading and tailing edge, which is good. Then it's level. Well, now I will deburr this one. Wait a minute. Done. So, well, okay. Then I'll put this a little bit inside there. There you are. And then I can use this one to zero my dial. Here, okay, like that. And then I can lock it there. And now, wow, like that. Oh yeah, it's okay. Good. now leveling this surface, getting rid of the scale, and well, yeah, so it's resting on the two parallels, and well, clamping it so much seems to be overkill at this time. Yeah, it is, but I need to move these while I'm progressing from this side to here. I need to move them, so I need to have at least two per side. So yeah, so the cutting speed will be 350 revolutions per minute. The feed per minute, and the feed will be 20 millimeters per minute. Yeah, okay. And the cut depth will be 0.25 millimeters, no more than that. And yeah. So now this workpiece has been debored on the backside. All the edges here, which are now under there, are debored, and the surface became really nice. Unfortunately, you cannot see it right at the moment because it's, well, it's against the table. So now we are milling recess for the motor here. So we should make it so that there remains 13 millimeters here at the bottom. So it should be 13 millimeters thick after this milling operation. And it will be, well, just to be somewhat consistent. The width of this is 98 millimeters, so I will mill it 98 millimeters this way. So there will be a recess, a quadratic recess for the motor. This is going to be the motor side. So now, well, this is a roughing end mill. I'm going to run this about 110 millimeters, 110 revolutions per minute, and the feed rate will be 40 millimeters per minute. And I'm using this Rockall paste for cutting fluid. Yeah, I just put something here. And after the first pass, oh yeah, okay, and I will be milling 4 millimeters at first. I will see how it does. Maybe I increase it to 8 millimeters. Let's see. But there will be a lot of chips, and well, yeah. So let us start milling this. Okay, the roughing is now done. Well, it was quite a lot of chips, but well, I could manage them. Now, this is our goal thickness here is 13 millimeters, and now this is 13.1. So I'm peeling 0.1 millimeters off, and after the first pass I will check whether it is 13 millimeters or not. So let's do this. Well, okay. Now this recess is really nice. You definitely can see the edges here, but there is nothing you can feel. If you close your eyes and then wipe this like this, you cannot tell where it cannot be felt. So it's really, it's just optical thing. So now we still have this surface here, which we have here 2 millimeters to take off, and I left intentionally that much there. So now this is a 10 millimeter carbide end mill. I'm going to first mill 1 millimeter, then 0.9 millimeters, and then climb mill 0.1 millimeters back, which should leave a decent finish. And I'm running this at 500 RPM, and the feed is 30 millimeters per minute. So I have no idea how this end mill behaves, so let's see. Well, what do you know? Okay. Then we go. Let's see. What's this stuff? dust. No real ships, these are just dust. Okay. Okay, but the surface feels good. I don't know how it looks like. But, well, it's a decent surface. Good. Okay. Now, the recess for this motor is now ready. So now I have depulled this piece, this motor recess here, and well, it is quite good. Now we need to drill 5 holes into it. So, and in exact places, nevertheless. So, well, I will now present you how I set up the coordinate system here, because here I have a paper which contains all the coordinates of those holes. And yeah, this milling machine doesn't have a DRO. So everything is done by mechanical scales. So let me show you how this is done. This here is a mechanical edge finder. It has this moving part which you can see it moves around like that. And well, this one is Starrett, and well, it's a quite good quality piece of equipment, but nevertheless this reading those is like reading tea leaves. You, they don't give you an exact place, really. Well, quite exact, but not that much. So I'm running this now 500 RPM. Those like to be run quite fast, not slowly. And let's see what happens when I approach the center, the edge here. So now I'm approaching the edge, and it should stop wobbling at some point. There you are, and now it will kick to the side, like that. Now I know that this is our zero. I reset my dial here in the, unfortunately you cannot see me resetting the dial. I pull it back and then go back, do this again. Just to ensure that I have the correct place here. There you are. Yeah. Okay. And now, this isn't now the edge. It's actually this diameter of this pin here under is 6 millimeters. So our edge is 3 millimeters away at the moment. So I need to move this like from the 0 point, which was here, I think. Yeah. So 3 more millimeters. There you are. And now our next step will be to set the dials. Okay, let me show you something here. This is now the dial. I have locked this. This is the table lock, and now this needs to be zeroed. Oh man, this is so. Hopefully I can get it to 0. Okay. You need to take care of the backslash here. That's 0 now. I can lock that there. Okay. And well, this is for fine tuning. But then we also have this one is the scale which is taking care of the well, it's the table scale, so I will also reset this one to 0. So then I can, then my machine talks me millimeters in this scale and hundredths of a millimeter in the fine scale. There you are. Oh, this is not easy to set up by one hand. Oh, where is it? Looks like. I'm trying to lock it. Is it still on 0? Yeah. So, just making sure that we have. Now, when I want to move to some amount of millimeters, so I move coarsely here with this scale, and then I take this scale for the rest of it, the fine tuning. So then I can go quite easily to a place. And now the same thing, this operation with the edge finder is repeated with the y-axis. This was x, and now y. Let me see if I can put it in an angle so that you can see it kicking off. Well, maybe there. You know, I also can use this for magnifying. Okay. And now we do the same with the x, I mean y-axis, this axis. And let's go. Reset the dial here. Do it again. Yep. That's the place. And now let's pull this out from here. So we need to go forward 3 millimeters, the radius of this edge finder pin, like that, and then I will reset my dial here. And for this one we have a, well, this dial is now reset here. And then we have, wait a minute, that one, yeah, here under under the machine we have here another dial, that one. This I would like to put on some exact millimeters. We cannot use the 0 here at the moment, so I put it on 3. Let's see, well, I need 2 hands for this one. That's basically how you do it, and after that we have a very we have our origo in this corner here. Well, focus is not working, but yeah, in that corner there. So this means that my paper where I have all these figures, I can use directly the millimeter readings from that, and that's good. So now I will first set up that Y scale because it's so it's really something. Okay. Now I'm drilling 4 5 millimeter holes. This is a Dormer split point 5 millimeter drill. It shouldn't wander too much when so therefore I don't have the starter holes. So there will be 4 of these, and this is the tapping drill for M6 thread. There will be M6 threads 4 where the motor is attached from this side. So now I just drill those 4 holes. This is already set at the first coordinates. Next will be somewhere here, and then I go back maybe here, and then the last one. Okay, let's do this. Now the last hole here in the center will not be a hole, it will be a center, a center. So let's do this. So it is, the coordinates are 49 slash 49. And then, now it's probably too much. Good. Yeah, that's ready. This is now the cycloid gear base. It will be attached to the motor base by a taper. So it will be pushed from here into the taper so that it will hopefully not lock permanently, but lock itself there when the motor is tightened. So I will now make a 20 degrees included taper here. So it will be 10 degrees per side. This scary setup is just to dial in this workpiece into my lathe. Well, it's really unbalanced and anyway, the tailstock is now pushing using this dead center the workpiece into the jaws. I have here two parallels under, so it hopefully it keeps it in place. So now I'm trying to dial this in. Well, maybe I give you a better view of this all. Wait a minute. Well, a pilot hole for bigger drills. This is a 7.5 millimeter drill. And why is that? This is because I have not used this drill a lot, it's probably sharp. This is the highest speed I dare to run this now. Yeah, it's really didn't like this speed. Well, yeah. Well, this is now 17 millimeter tree. Hopefully this likes the speed better than the previous one. Or the slowness, so to say. Yeah, definitely. This is way better. $17 done. And finally, the last drill before we start boring. This is the biggest one I have. This is 29mm. So, well, let's see. I had to slow this down. This would have been too fast, but this is probably the suitable speed. So let's see now. Well, that was a 29mm hole. Yep. Well, at the moment the diameter is 62.45 millimeters, and well, our goal has changed. I was reading my micrometer the wrong way. The correct diameter where we aim to is 71.3 at the moment. So, well, this is yet another 2mm cut. Let's see where we are now. Oh, some long ones. Yeah. So, oh man. Oh yeah. It's a little bit difficult to measure now. Okay. Oh yeah. Okay. 70.32. Let's see now. paper into this workpiece. And this is, well, it's just, well, first I will take only 0.2 millimeter cuts here. And, well, I will test it every now and then because it's really easy to overdo this. And if I do that, then I'm in trouble. So I don't want to get into trouble. So I will take 0.2 millimeter cuts. Okay. Oh yeah, now it is there. So, well, it's only 1/10 of a millimeter. Well, then measure. Well, it looks like it's correct now. So. It's actually very good. It's 1.55 and that's, I leave it there. Okay. Well, if you break a tap into a hole manually, what's the fun in that? Well, but if you can do that with a machine, yeah. So let's try not to break the tap this time. Well, this is a Tapmatic tapping head. Reversible means that I can do my tapping quite simply actually. Like this. Did it go through? Well, let's try. Yes, I believe so. Next hole. Let's see now. This has some flex in this. It's well, it's quite a lot of actually. Yeah, this is a gun tap. You shouldn't try the normal taps with this one. They will break because you have to evacuate the chips every now and then. And if you don't, they break. So it has to be a spiral flute or, like in this case, a gun tap. Hopefully it went through, I don't know. Well, it should, but you never know. Oh, yeah. So actually the purpose of this flex here is to allow the tap to center itself into the hole. So yeah, okay. A little bit more of this stuff. if you have something like 20 threads to tap, so then this is wunderbar. There you are. Done. Well, the setup time for this kind of thing is something like 5 minutes. When you have 4 holes like this, which all have the same type of thread, then it's probably a good idea to use this. But if you have only 1 or maybe 2, then it's not a very good idea. Okay, so let's try this out. So this is now, this thing goes there, and then we have this which has the taper matching to that one. This goes here, and then we put a few screws here under, like there first. Then here. Oh man. Where are the 2? This one is tight a little bit. Not too much though. No, nothing special. Just there. Now let's see that we tighten it evenly. Oh yeah, okay, let's see if I can do this like this. This motor is magnetic. Oh man, it's really magnetic. Okay. I'm pretty sure when this is in place, it really is in place, and it looks like, feels like, and it's evenly there. And now this won't rotate. There is a half a millimeter gap here, and when I tighten this, it will push this against the taper, and it will stay there. This is a spring spacer which I have been using down there to. Okay, now I can put this like that. Yeah, now it's there. And then I had this, I was telling that I need to make a key for this one because this is mutilated, and it was me who mutilated this one. So now that's there, and this is always a little bit difficult to put in place. If, yeah, okay. Does it turn? Yes, it does. Good. And now the pins. Is there a direction here? This should be irrelevant which, well, but it's not. Seems. Okay. Now the pins. 40 of them. Oh. There is no oil, it's dry at the moment, so we can see what it does. And this is really quite powerful and it's smooth. Yeah. And it tends to come up from there. Please stay in place. Yeah, okay. So what this means is that our motor is straight with this. So if the taper, for example, would be a little bit crooked, that might be now that might be a problem in here. And what I will do now, I will actually put the lid on, all the screws there. Oh yeah, now it's powerful, really powerful. Yeah, okay. In the next episode of Finno Grip Machining, we are going to machine this base even more. There should be something like this, a radius here, which matches the welding position. And then it will be attached to the welding positioner with two pins, which come from the round body. And then we have some tensioning system, which then when you tighten it, it stays there and doesn't come off. Okay, that's ready. Well, till next time, see you!